All right. Okay, ladies and gentlemen, let's try to record this here. So here's what we're going to go back and look at. This is our Cartesian coordinate system, if you guys recall. And the XY plane here. So remember the following. If we try to draw an arrow, and yeah, we'll do it. We'll change that color. Okay, so we're fine, but does not want to change the colors. Okay. So what you guys are looking at is a ray. So let's see if this works now. So we're looking at a ray in standard position. And now this is, what's the deal? Okay, so let's try to see what's going on here. All right, maybe that works. All right, there we go. So you guys are looking at a ray. Remember, this is called being in what we call standard position. Okay, it's on the positive x-axis here. So you got a ray in standard position on the positive x-axis. Now let's note a couple of things here. When you rotate that ray in standard position counterclockwise, what do you guys remember about the central angle? Right, the central angle is what? Positive. Is that true? Okay, you guys okay with that? And then when you rotate the ray clockwise, what happens to the central angle? Central angle is negative. Okay, you guys okay with that? And so I want you guys to recall this. We take a ray in standard position and we can rotate it. This is 90 degrees, 120 degrees, right? 180. 270, 300, 330, and then back to the standard position, you start at 0 degrees. But if you guys notice, that rotation here, right, gave you a 360-degree angle where you actually have that same terminal point. Okay, where you have the same terminal point here. Now, what is happening with these iPad 10? Do not know. Anyway, okay. So that rotation gave us, ladies and gentlemen, a 360-degree angle. And what I want to do now, if I can write here, the following. Okay, so remember we have a terminal point here. So if I draw a circle, and that's what we were doing. We can make that circle very big. Something like that, okay? And as you guys know, we have a terminal point. Is that right? So the starting terminal point is associated with our 0-degree angle. And rotating 360 degrees clockwise positively gives us another angle of 360 there, right? We start at 0, We rotated. This is what we're doing. We're rotating that 360 degrees, ladies and gentlemen. And we have the same terminal point, is my point. So this was the terminal point. These angles, they share what? The same terminal point. Okay? Whatever that point is, they share it. Do you guys agree with that? So even if I rotate again, another what? 360. How many degrees is that now if I do this whole thing again? What do you guys think? I did 2 rotations. Is that true? So 2 rotations, what's my angle now? I add another 360. So here's what I'm saying. Add another 360. What does that give you? 720. Is that true? And then we share the same what? Terminal point. And I could keep doing this all day long. Do you guys agree with that? I could keep rotating this ray along that circle counterclockwise, and I keep adding 360. Is that true? So I want you guys to understand that detail. That's very important. Now, you say to me, what if we did the opposite, right? Let's see what theta is this. What do I mean by the opposite? What if my rotation is in the other direction? That means, what did I just do? I rotated clockwise. If I rotate clockwise, I moved a distance in rotation there, what? A negative angle. Is that true? Because it's a clockwise rotation. Now, what does that measure? Negative 360. And I share, here's the point, we share the same terminal point. So I can keep doing this. I can say, I'm going to rotate again in the negative direction, okay, another 360. So what I do now is I'm still doing what? I'm subtracting another 360. What does this measure? Do you guys know what that measures? If I subtract another 360, that measures negative what? 720. So what I want to emphasize to you guys is extremely important here, this rotation. This ray, whether you rotate the ray clockwise or counterclockwise, if you do it in such a way that you're at the same what? Terminal point, that's going to have some meaning for us. Okay, so that's the idea. You're rotating a full revolution. And that's what we did, either clockwise or counterclockwise. So I want you guys to note that very important detail, okay? All we did is rotate a full what? Revolution. Either clockwise or counterclockwise. Okay? This must be a full what? Revolution. Okay? And what that does is it guarantees we are at the same what? Terminal point. And we call that TP, right? So is everybody okay with that idea? You guys see the point? So let me also remark, let me do this, okay? I'm going to erase this, and I'm going to say now, we're going to start at an angle like 30 degrees, okay? So that's going to be our starting location here. And on our circle, we can do that. Let's undo it. I guess I'm going to try to erase that if I can. But on our circle, that's the starting point. That's your terminal point. And I rotated to start 30 degrees. Okay, so this rotation is 30 degrees. Now, what if I start at 30 degrees? So I'm going to say here, theta equals what? 30 degrees. And I'm going to rotate a full revolution, a full rev, okay? One full revolution. That's what I want to rotate. This is kind of weird. Here we go. Here's where we start, and I'm going to rotate again. How? That is counterclockwise, one full rev. You guys with me on that? What does my angle measure now? You say, what are you talking about? Well, I'll do it again. I started here at 30 degrees. Okay? And I rotate one rev. What's one revolution? 360. Good. So if I do that, I take the starting point of 30 and I add 360 degrees. What does that give you now? 390 degrees. And my point is you share the same what? Terminal point. Because this is by nature of a circle. You can rotate full revolutions all day long. And if I said, let's do a second revolution now, okay, what's the angle now if I end up at the same terminal point? I keep doing what? I keep adding what? 360. So that'll be 390 now plus 360. And then what is 390 plus 360? Is that 750? Okay. So here's my point to you guys. 30 degrees, 390 degrees, 750, they share the same what? Terminal point, okay? So there's nothing special about a rotation that's counterclockwise. What if I started again and rotate a full revolution in the other direction, ending up at the same terminal point? What do you guys think my angle will measure now? Remember, you started where? At 30 degrees. And you rotated clockwise. What does a clockwise rotation do? It's negative, is that right? So I now take that 30 degrees and I subtract 360 because this was a clockwise rotation and over here was a counterclockwise rotation. So what does that angle measure now for you guys? What does that measure? What is this? 30 degrees minus what? And that's a negative 330 degrees, ladies and gentlemen. So I want you guys to know that you can rotate in the other direction on a circle, a full revolution to end up at the same terminal point, and you have another angle. Okay, but they're equivalent in some way. You say, what do you mean they're equivalent? Do you guys know what I mean by being equivalent? What do I mean by that? We're going to have to define this situation because I can again rotate, ladies and gentlemen, clockwise another full revolution, and that's negative 360. And yet again, what does that equal? So we say negative 330 degrees minus another 360. That's a full revolution. And then that's going to give us negative what? 690. Is that negative 690 degrees? Okay. And so, ladies and gentlemen, again, we can start at 30. You say, is that my starting point? Yes. Okay. And we can do the same over here. And you could actually rotate either clockwise or counterclockwise full revolutions, 360 degrees. It must be full revolutions, and you're going to end up at the same what? Terminal point. You guys with me on that? Okay, now, I'm going to give you guys a definition here because this actually has some meaning for us. Okay. Definition here. And I'm going to see how your book kind of, well, what does your book say? How does your book define it? Yeah, your book doesn't really, okay, two angles. Yeah. Well, here's what I'm going to say. Two angles are coterminal if they share the same terminal point. And this is where we get the word coterminal, okay? So it's coterminal, sharing the same terminal point, but that only applies when you're doing some what? Rotation here, okay? In some ways. There's a formula here, okay? Here's a fact. I'm going to say this to you guys. You're going to let, what should we say, A and B or alpha and beta be two angles, okay? This is the formula version of the definition. So alpha and beta are two angles now, okay? Two angles. Alpha is the same as beta plus 360 degrees times n. Okay? This is what that means to be terminal. Okay? Alpha and beta are coterminal. So let's look at this in detail. This is the formula I want you guys to see here, okay? This is the big deal. So you got two angles here, and one's alpha, and then the other is what? Beta. They're coterminal, share the same terminal point. But what do you guys think this means over here? What is that?
The number of rotations.
Yeah, that's the number of full rotations. One rotation or one revolution. So let's look at the detail. This is the detail. Number one. One revolution, also thought of as a rotation, equals 360 degrees. Are you guys okay with that? One revolution of that ray on any circle here. So one revolution equals 360 degrees. That's the first fact. The second fact is I'm going to say n revolutions or rotations, okay? That equals 360 degrees times n. But what is n, ladies and gentlemen? Well, it's the number of revolutions. That's true. But what I'm saying is n is 1, n is 2, n is 3. In fact, we could rotate forever. Now, if you have n being positive, what does that correspond to? Counterclockwise rotation, okay? Now, you can actually even have n being negative. -1, -2, -3 forever, and that corresponds to what? Clockwise rotations, okay? You're going in the other way. So you might say, what do they even say? What does that really mean? Well, this information right in here, we'll put pink, I guess, I don't know. That information there, we're really talking about what's called the integers, okay? The integers is a set of all real numbers. I'm sorry, not real numbers. Very wrong. This is what the integers look like. Okay? These are integer values. And that's an important detail, integers. Okay? Because very often what you'll see in a definition of being coterminal is this. You're going to say n is an integer. Integers are represented by that set with a capital letter Z here. Okay? That's what I'm talking about. Here's your Z. These are the integer values. Okay? So this gives you a very, very easy way to generate coterminal angles. All right? You guys understand what I'm saying? This formula allows you to generate coterminal angles. Let me show you guys how to use this. For example, they're going to say this. Determine, let's say determine four coterminal angles. Terminal angles. So example, you're going to start with 45 degrees here, okay? We start with 45 degrees. We want coterminal angles. So you say, well, how do I do that, right? Well, you're going to use the formula. You say, what's the formula? Well, you can say alpha equals beta plus 360 degrees times n. N is an integer. This is what we can say mathematically speaking. So you might say, what do I do? Well, you take that 45 degrees, put it right in here. This is where you what? Start, ladies and gentlemen. Okay? So that's your starting point. So you say, do I start with 45 degrees and I just keep adding what? Integer multiples of what? 360 degrees? And the answer is what? Absolutely. Okay, you guys okay with that? So you say, okay, what do I do? Well, start with n is 1. What's your next coterminal angle? 45 degrees plus 360 times 1. Remember what I say, arithmetic, ladies and gentlemen? What's 360 degrees times 1? Isn't that 360? So this is 45 degrees plus what? What does that give you? 405 degrees. Good job. So ladies and gentlemen, this is the second angle. This is the alpha in our formula. And what did we say, ladies and gentlemen? We said alpha and beta are what? These are coterminal. This is your formula here. So I don't have to go back to the graph and say, okay, start here at 45. Yeah, I don't know what I just did, but okay. Start here at 45, okay. I got rid of the circle. You don't want to do that. Here's a terminal point. Yes, I don't have to graphically say 45 degrees plus 360. We can do it using this what? This relationship, this formula, because that's what it means for angles to be coterminal. They share the same terminal point. Your book says they share the same side, the ray. Okay, same thing. But I actually like to use terminal point because it's in the phrase coterminal. Okay? So I use that phrase coterminal. Share the same terminal point. So if I have to find coterminal angles, 45 degrees and 405 degrees, what do we know? They share the same what? Terminal what? Okay? Now, what is the instructions? To find what? 4. So this is only one. What would I do to find another, ladies and gentlemen? I could do a couple of things. I can now go back to my formula and say, okay, n is 2 now, which means we start with 45 and we add 360 degrees times what? Times 2. What does that give you? 45. What's 2 times 360? Isn't that 720? And what's 45 plus 720? 700 and what? So what did you just find? A second what? Coterminal point. These angles are coterminal. Sorry, they share the same terminal point. You found a second coterminal angle. Okay, what would you do now to get the third? Well, if n is 3, what do we have? 45 plus 360 times 3. And what does that give you? 45 degrees plus, what's the 360 times 3?
180.
Is that 1,080? What's 1,080 plus 45? Do you guys know?
1100.
Is 1,125 degrees. Good job. So this is my next what? Coterminal angle. How do we get the fourth one? What do you guys say? N here is now going to be what? 4 alpha is 45 degrees plus 360 degrees times 4. What's 360 times 4? Maybe you said, Mr. Judge, I'm going to go to my TI calculator and I'm going to get this calculator out because I'm going to use it with another class later. 45 plus 360 times what? 4. What do you guys get? Is that 1485? Can you guys see that there?
Not really.
I don't know. I kind of miss the old laptop. It's still in the shop. Apple, I guess they can't find, I guess they're finding problems. I have no idea. So that's 1485, 1,485, by the way. So 1,485 degrees, okay? So you can actually do that as well, okay? Now, what do you guys notice about all these coterminal angles to 45 degrees? How did I rotate? Counterclockwise or clockwise? Counterclockwise. How do you know?
It's positive.
Because I am using positive n values. Is that right? So n is positive 1, n is 2, n is 3, n is 4. That corresponds to the counterclockwise rotation. All these angles were rotated counterclockwise. So what I'm going to say this, I'm going to say, what about clockwise rotation? What's going to happen now for clockwise rotation? Well, I'm going to start now. I'm going to say n is what now? -1. What was your formula? Alpha is 45 degrees plus 360 degrees times n. So with a clockwise rotation now, replace my n with what number? And what does that give you? That says alpha will be 45 plus 360 degrees times -1. Let's do the arithmetic ourselves. What's 360 times -1? It's -360. Is that true? All right. Now what's 45 degrees minus 360? Is that -315? Is that true? So, ladies and gentlemen, we got now, notice this, another coterminal angle to 45 degrees. It's negative though. So all we did in the picture is say, okay, start at 45, now rotate what? In the other direction. What angle measure are we talking now? That's negative 315 degrees. Because moving in the opposite direction, clockwise, gives you a negative angle. Okay, you guys okay with that? So, that's the clockwise rotation. And then, what if I just did this? Well, what if I said, I'm going to rotate 6 full revolutions clockwise? What's the coterminal angle? Well, you'd simply use your formula. You start at 45, 360 degrees times n, but this time my n value right in here is what? Notice this. N will be negative what? 6. So, if n is negative 6, alpha is 45 degrees minus, plus 360 degrees, right, times negative 6. Now, you may not be able to see this. Parentheses, negative 6, close that. What does that equal? That's actually, you guys can't see that. It's negative 2,115 degrees. Okay? Negative 2,115 degrees. So I'll write it down here. Negative 2,100 and what? 15 degrees. So this here is the next what? Well, it's not the next coterminal angle, but it's an angle that's coterminal, shares the same terminal point. If we did now, how many revolutions? 6 revolutions, 6 rotations in the clockwise direction. And that all comes from the idea that you are taking an angle and rotating, because this is a what? You're rotating full revs, either counterclockwise, or full revs what? Clockwise. That's where this comes from. And you can start at any angle. Doesn't matter what the angle is. Okay? We're using this definition of being what? Coterminal. Which gives us, really, this formula. Okay, but that's how you use it. And this angle is always where you what? Start. Easy peasy, lemon squeezy. It's, again, what's the word? Arithmetic. Okay? So let's give you guys you have a question? No?
Yeah.
Okay.
So that, like, basically you can find a coterminal point of any angle, right?
Any angle. You can find the coterminal angle, right? And you say, what's the coterminal angle? Well, when after you rotate full revolutions, it has to be full revolutions. You essentially end up at the same starting point. Is that true? Does that make any sense to you? Because this is a what? A circle. So, for example, let's say you're now going to take, I don't know, a 200-degree angle. Okay? Determine the coterminal angles for what? Revolutions or rotations, whatever you want to call it. Determine these coterminal angles when n equals 1, 2, -1, negative 2, and let's do this. Let's say 5, negative 1, negative 2, and negative 10. So you might say, what are you really asking me? Well, when n is 1, how many revolutions is that? Yes. So n being 1, positive 1, means there was 1. We don't say full revolutions. We just say revolutions, or we say rotations, okay? N is 2. What does that mean? 2 what? Revolutions. Okay, you guys okay with that? Or rotations. How about we just copy that? Let's copy that. N is what? What is n is 5? 5 what? Revolutions or rotations, okay? N is negative 1. What does that mean? 1 what? Revolution or rotation, but in what direction? Well, clockwise when it's negative. Yes. When it's positive, it's what? Counterclockwise. Okay? You guys get my point? This is a small, well, not small, this is a big, important detail. So I want you guys to find coterminal angles to what? 200 degrees. I'll give you guys a few minutes to do that. Okay? Let's see what you guys get. Let's see what you get with these. You're really just using your what? Formula, that relationship. Let's get out the clock. How long will that take? We'll see what we get. Did everybody copy this down? Beginning of the notes. Okay. Scroll up.
Scroll down.
You good?
Keep going.
Keep going.
Keep going.
You're going to have a video or a PDF file.
One more.
Okay. What do we do, ladies and gentlemen, for one full rev? What does that formula say? To get a coterminal angle, an angle that's coterminal to 200 degrees, what do you guys do? You start at 200, you add a multiple of a revolution. In this case, they want you to start when n is what? 1. So here you replace n with 1, okay? Now 1 times anything is itself, is that true? So doing some arithmetic, 200 degrees plus 360 gives you what? 560 degrees, is that right? So ladies and gentlemen, what'd you just find? 560 and 200 are coterminal. Okay, they share the same terminal point. So you're going to do the same thing now, but this time when n is what? N is 2, is that right? And, all right, well, let's move all this down, okay? So now n is 2, so replace this 2, you get alpha is 200 degrees plus 360 degrees times 2, 200 degrees plus what? What's 360 times 2? So what's 200 plus 720? Is that 920 degrees? There you go, ladies and gentlemen. And let's actually color that orange. These are all the other coterminal angles here. Okay? There we go. Now, when n is 5, what do you think we do here? You replace n here with what? 5. So this becomes 200 degrees, 360 degrees times 5. Okay? So now again, you have 5 revolutions. And I'm going to get out that calculator. 200 plus 360 times 5. What does that equal? Do you guys know? Well, 200 plus 360 times 5, what does that equal? 2,000. So you guys could use your calculator to do that. That's fine. 2,000 degrees. Okay, now you say, well, what about if I go in the other direction? Well, now n is what number? N is going to be what? N is -1. Is that true? So what does that mean? You're going to say, we start at 200 degrees, 360 degrees times -1. I'm going to use my brain on this one. So 200 minus 360, isn't that -160 degrees? Okay, you guys okay with that? And there you go, easy peasy lemon squeezy. Coterminal. What else do they want us to do? -2 and -10. So now, if n here is -2, that's 2 revolutions now. -2, okay? That's 2 revs in the clockwise direction. N is -2 now, okay? So we get 200 degrees plus 360 degrees times -2. So we get 200 degrees. Isn't 360 times 2, isn't that -720? I'm going to use my brain again. that's going to be negative 500 degrees, okay? And I guess we're coloring these coterminal angles orange. There you guys go. Yes?
Shouldn't that be negative 520?
Oh, negative 520? I apologize. I can't use my brain if I don't have any coffee in it, right? And you are correct. Thank you. All right, you guys okay with that one? Easy peasy lemon squeezy. What was the other question? They want how many revolutions? Negative 10. So you go, oh, 10 revs in the clockwise. So, okay. Put down your formula and replace n now with what? Negative 10. Oops. All right. Alpha, 200 degrees. And you know what? That's minus what? That's minus 3,600 degrees. Is that right? So what is that going to give you? Isn't that negative what? 3,400 degrees. I was able to do this using my what? Brain, ladies and gentlemen. Okay? So I want you guys to look at this and say, okay, that's coterminal angles. Now, anybody have any questions on that? Okay, remember, it's based on arithmetic. Is that right? So here's what I'm going to transition to. I'm going to ask you guys, what about radians? Do you guys remember what radians are? What are radians? Yeah, radian measure. You remember we did that already. We even had that on your test, radian measure. Okay? Can we do this with radians? The answer is yes. Okay? But I want you guys to recall here. What is one full revolution? What is one full rev? Now, recall this on your unit circle. Okay? On the unit circle, what was one full revolution? Okay, because that's an important detail. You say, Mr. Judge, why does it have to be a unit circle? Well, let's go back. I'm gonna draw my picture this way for you guys, okay? A unit circle means my radius is what? 1. Is that true? That's 1 unit. So this is related to the circumference of your circle. Remember this? Generally speaking, it's 2 pi r, but if the radius is 1, that circumference is 2 pi. Okay? Times 1, which, yes, is 2 pi. What I'm saying is, if you rotate 1 full revolution, the distance you traveled, okay, remember, that's the terminal point. The distance you traveled along that circle, because that's what radian measure was. Is that true? Do you guys remember that? We had a test on that. So what is 1 full revolution associated with on that unit circle? This is what you guys want to know. Here's a fact. 1 rev is equal to what? In terms of radians. What's 1 revolution in terms of your radian measure? 2 pi. Good. So that's 2 pi radians. That is a big deal because the distance here is what you're talking about that you traveled along that unit circle. Because that's what the radian measure was. Okay, it's not the central angle, right? We're not talking a central angle anymore. This is radian measure. So 1 rev, ladies and gentlemen, on that unit circle where your radian measure comes from, is really what? 2 pi radians. Now, a radian measure is also known as a what? A real number value. It's a real number. So if I say to you guys, then what is n revs? N revolutions or n rotations, what does that measure? Do it n times. That's now going to be what? 2 pi n radians. Okay, you guys okay with that? And so you might say, Mr. Judge, where are you really going with this? Remember that formula I gave you guys here in degrees, where you say alpha equals beta plus 360 degrees times n? You're just going to replace that 360 with what number? What is it? 2 pi. Outstanding. Okay? So you replace it with the 2 pi, because 2 pi in radian measure on that unit circle is 360 degrees. Remember that? So I just want you guys to recall, we already knew that. That was on our first test. That 360 degrees is the same as that 2 pi radian measure. Okay? So your alpha is beta now plus 2 pi what? N. So we can do the same thing, but now with radian measure. And this is actually really where we're headed, ladies and gentlemen, if you guys want to know the truth. We're headed with the radian measure version for a lot of reasons, a lot of good reasons. So here's the question. Right? What angles are coterminal to pi over 6? Okay? So we're going to try to look at angles that are coterminal to what? Pi over 6. So we do pi over 6? How about this? Even better, pi over 3. Okay? There's a reason why I'm going to do pi over 3. Why am I going to do pi over 3 instead? Do you guys remember? What is pi over 3 in terms of degrees?
120.
I'm glad it's going to be on our homework as a review.
Oh, wait, sorry.
Isn't that 60 degrees? Okay, so you said, why are you starting with this? Because remember, we started the day, well, we already looked at 30 degrees and 45 degrees, right? Oops. So we're really saying, hey, start over here now, okay? And again, this is not with the central angle. This is in radian measure now. And if you want that detail, I'm going to run out of colors, but okay. This is the arc length, and this is now a unit circle here. This is pi over what? 3, 60 degrees. So if you started at radian measure on this unit circle, this distance is 1, pi over 3 now. We want to know about coterminal angles in terms of radian measure. And that's really where we're headed. So to start this off, you know what I would say? Try n is 1. Try n is 2. Okay? You guys see what I'm saying? Try n is what? 3. And do your arithmetic. Because 1 rev, and this is a fact, you guys want to know these facts, is 2 pi radians. N revs is what? 2 pi n radians. This portion in your formula, 2 pi n, is that n revolutions. So you start now here, and you say, okay, start at pi over 3, and you're going to say 2 pi n. But n here is what number? 1. That's 1 revolution, remember, in the counterclockwise direction. The rest is, what's that word? Arithmetic. Now, you guys want to get used to this arithmetic here. Pi over 3 plus 2 pi. And let me double check to see something here, and I want to see how your book wants to put their answers here. And, you know, this new setup is driving me crazy. So they put a new desktop in front of me, and I can't see you now. All right, yeah, okay. Yeah, here we go. We're going to have to do some arithmetic, ladies and gentlemen. Okay? Now, what are you guys doing? You're adding a fraction. You say, what's my fraction? Pi over 3. And then you add it with a whole number. You say, what's the whole number? Well, it's a 2 pi. You guys remember that? So how do we do the arithmetic? It's very simple. Multiply the top by 3 and the bottom by 3. So what does that give you here? Pi over 3 plus, anybody know? What's this new numerator? The denominator is 3. 6 pi, outstanding. And what does that mean now, ladies and gentlemen? What do you get now? Alpha is going to be what? 7 pi over 3. Good job. Can you guys do that arithmetic? Did you guys see what I'm saying? That's not too bad. Is that right? Right? You guys okay with that? So pi over 3 and 7 pi over 3 are said to be what? Co-what? Terminal. What about n here is what? 2. What do you get now? Alpha is pi over 3 plus 2n pi, and now is what number? 2. Is that right? This n. What does the arithmetic say? That alpha will be pi over 3 plus, what's 2 times 2 pi? Is that 4 pi? Okay, you guys okay with that? What does this mean here, this 3? You guys know? Multiply the top by 3, the bottom by 3. We're going to do this arithmetic. What does that mean? Pi over 3 plus 12 pi over 3. And what's that? It's 13 pi over 3. Ladies and gentlemen, there's your arithmetic. What do you guys think? Not too bad? Okay, let's do the next one. 3 revolutions. We'll find the next coterminal angle. They share the same terminal point here. Okay? Replace n with 3 here, and what do you guys get? Oops. Sorry. Copied the wrong thing. Let's go back. Let's copy this one. N is what number? 3. What does that mean alpha is? Pi over 3 plus, what's 2 pi times 3? 6 pi. What's the problem, ladies and gentlemen, like before? What do you guys have there? Multiply the top by 3, the bottom by 3. What happens with my arithmetic, right? You get pi over 3 plus, what's this? 18 pi over 3. Can't we add this now? This is now what? 19 pi over 3. Okay, you guys with me on this? All right, what if I said to you, they want to give you what? Negative rotations, 4 revolutions now. Okay? 4 revs. What would you guys say here? Replace your n now with what? -4. This is going to be 4 revolutions in the clockwise direction. Is that true? So let's do the arithmetic. What's this? Pi over 3. Now, what is this going to give you guys? What's 2 pi times -4? What's that going to give you? Anybody know what that is? 2 pi times -4? What's that going to be? -8 pi. Okay. Can you do your arithmetic? You guys know what I'm saying? What am I saying? You're going to multiply the top by 3, the bottom by 3. Alpha is pi over 3 minus what? 24 pi over 3. What is that going to give you? Negative what? 23 pi over 3. So the point I'm making is, ladies and gentlemen, you're going to do a little bit of arithmetic to find these coterminal angles. But what we're really headed to is the idea of radian measure, ladies and gentlemen. Radian measure is your scientific measure. We're going to see physically why we care about that. But I want to introduce you guys to another kind of idea here. Okay? I'm going to go back to our circle here. And I'm going to remind you guys, since we already did with this some of these radians already, and you're going to see some of the homework that we have. I'm going to do this. I'm going to say now, we're going to go back to a general circle. Circle of radius r. Okay? And I'm going to do this here. Now, we have a central angle. Okay? Theta. And this distance, remember this distance from this point, you can call that your initial point, terminal point, whatever. What was that called, if you guys remember? What was that distance along this circle called? Remember, your radius here now is r, but okay, what's that called? You guys remember? That's your arc length. Good. That's S for arc length. Is that true? Remember, we gave you that? We called that. That's where your radian measure came on the unit circle. But the question now is, okay, 2 things. What does that actually mean if it's a general radius, not a unit? Well, arc length, ladies and gentlemen, is given by the formula SR theta, where this angle has to be a radian measure, okay? So I want you guys to know this formula. I'm going to put that in red again. Again, this is a general radius value. This isn't radius 1. This is radius r. So this is what we define to be our arc length. S equals r theta now. Now, r is not 1. R could be any angle. Any radius value. Okay? S is r theta. Now, do you guys happen to know, what is this a picture of, by the way? Anybody know? You say, what do you mean picture? What is that a picture of? Right in here. This is called something. It's not a triangle, but thank you. It looks like a triangle, doesn't it? It's similar, but it's not a triangle. Why is this not a triangle? You know what a triangle looks like? That's a triangle if you had a straight line between those points. So this is why I say thank you. It's not a triangle, though. So you see that arc? That's why they call it arc length. It's not a straight line. That's an arc. Is that true? See the picture physically? But, and I want to thank you for that because we're going to go back to this idea. It's related. But what is this picture again? Anybody happen to know? I wish I had my sound effects. What's that a picture of? Uh-huh. Is it a cone? No. You know what I had for dinner last night? I shouldn't have. My wife went to Costco. You know what I asked her to bring? I couldn't finish it, so. You know what I asked her to bring? She's going to Costco. Of course, what did she say? Can I have your debit card? And it's like, oh my God. Jeez. That's like the worst place to go with your debit card. You guys know what I'm talking about? So my wife went to Costco. She goes, can you give me your debit card? I'm like, oh, God, please. No. And I said, what are you going to get? Uh-oh. Oh, shoot, my wife's in the room. So what are you going to get? Stuff we need. I'm like, oh, God, no. The worst thing to say. Stuff we need. We don't need anything, do we? Anyway, I said, bring me a pizza. Pepperoni. Not the whole thing, but bring me a slice of pizza. What does this look like to you guys? Does that look like a pizza slice? In theory. I know they don't look as nice as this. So I can say, that is a pizza slice. That is a, oh, anybody, what's your favorite pie? You can say pizza pie is my favorite. Okay, no. Fruit pie, what's your favorite pie? Just kind of curious. You like blueberry pie? Oh, good. Anybody else? Apple? Yes. I can say I vote for apple. I like blueberry too. If you could get a good berry pie, that's good too. You can't always get a good berry pie though. That's a tough one. Anybody have any other favorite pie?
Taro pie.
What is? Oh, taro pie. Oh, there we go. Nice. Taro pie. Yes. Any other pie? Apple, blueberry, taro. I think I could go with you guys to have some dessert. I think that'd be fine. Well, I'm bringing up pizza and pie because that's the shape you're looking at. You know what we call this, though, in geometry and trig, though? This shape. This is called, ladies and gentlemen, this is known as a sector. That's a sector. It's not a triangle, though, but it's a what? It's a sector. And so very often, to say to you, we got some very nice formulas here regarding that shape. And okay, that's kind of more like my pizza last night, but anyway. You got the central angle, okay? You got the radius, and this is the same radius, by the way, and you got S. And this is called a what? A sector. Yes, what do we know about a sector? S is r theta. You also want to know what we know? I'm going to give you guys a nice formula for area. It looks a lot like something you know. 1/2 r squared what? Theta. Okay? And we're talking area of a sector. You say, what do you mean? Yeah, you see this here? We could compute the area of this sector. Okay, and what do you need? You need a radius value, okay? And remember I said this here? Your angle theta, this is an important detail. I might have to put it in, I don't know, we'll put it in pink, okay? Pretty in pink. You see that angle theta? What does theta have to be measured in? You must have theta in this measure. Theta is in what? Radians. Okay? Not degrees. Even they go, but Mr. Judge, that's a central angle. And I'll say, I know, but we're transitioning from the central angle to the radian measure. And it's the scientific measure you'll see in our future. Degrees are great. We still think about them. But, you know, we're working with radians. And radians are another way of saying just a simple what? Real number. So it's your real number value. But you want to go home today and you want to get a slice of what? Pizza for dinner at Costco, a nice greasy pizza. And then for dessert, have a slice. Don't even say slice anymore. If your wife says, hey, what should I bring from Costco? Bring me a sector of pizza. And bring me a sector of blueberry pie. Get that word out. Get that word into your vocabulary. A what again? A sector. All right, you guys see what I'm saying? And we're going to have to start dealing with, we're going to deal with this in much more detail. But we're going to start to deal with that in detail. Let me double check something here. Okay. Things I'd like you guys to do for homework. Yeah, okay. Let's go here. And I'm going to adjust it for you guys here. Okay. Just going to adjust it for now. So I'm adjusting your homework on this for now, ladies and gentlemen. I'm going to just make sure it's, how can I put it, really up to date. And since I'm on the I'm there here, I'm going to kind of do a little other something here. Okay. And we should be good to go, ladies and gentlemen. So be prepared tomorrow to talk about what? What's this picture? Sectors, okay? All right, and I'll see you guys when? Tomorrow. Okay, good.